Okay, so on here we have them both graphed, okay? And I did a really poor job graphing it there. So here's our line y equals x. That's what it reflected over. So if I want the domain for my original graph in interval notation, what's my domain? Intervals. Try again. Negative infinity to your domain.
Positive infinity.
Positive infinity, thank you. What's your range?
Negative infinity.
2
Stops at 4.
to 4. Good. So that means for my inverse, the domain and range are going to switch. So my domain is negative infinity to 4. And my range is negative infinity to infinity. Okay? So, again, talking about restricting the domain, if I cut it in half right here and only worry about part of it, then we can say the inverse is going to be a function. Okay? If I just have part of it, what parent function is that? Here, I guess we're used to saying it this way. Square root. Yeah, it's just a square root. Now, if you notice, this is opening to the negative numbers, right? See what I'm talking about? Going to the negatives? Which way is the red one opening? To the what? To the negatives. Which way is this one opening? Which way is that one opening? Okay, over here. Slope of the original was negative. Slope of the inverse, negative. Oh, here's positive slope. Positive slope. Well, then we did perpendicular there. Dang it. Well, okay. Positive slope, if we stick with this one, positive slope. So your slope, or your A, depending on what kind of graph we're dealing with, the positive and negative part of that does not change. So if you start out with it being negative, and you find the inverse needs to also be negative. They shouldn't all of a sudden turn into positive stuff. Okay? So again, horizontal line test. The quadratic is going to fail the horizontal line test, which means the inverse is not a function unless we restrict the domain. What other function that we can get right all the time on tests would not have an inverse? Absolute value, the one we can always get right. Okay.